Zalot studio channel. Zalot studio channel, that is virtual physics lab, which is a simulation lab. So welcome. Rotational dynamics. Just as before, dynamics is a branch of mechanics concerned with the force that causes motion of body. Motion of body. Therefore, what torque mean? Torque is the turning effect. The turning effect, or the twisting effect. The twisting effect applied to an object that tends to make the object turn about a certain axis of rotation is called the moment of a force. So a torque tau, this letter that is tau, that is a Greek word tau. The torque tau is the total moment acting on that body about the axis of rotation, and it's measured by multiplied the forces by its perpendicular distance from the axis. So torque is equals F cross R, F cross R, F times R. This cross means the vector product, here the two vector, force is vector and radius, that is displacement, is vector, that's a perpendicular radius. Therefore it gives torque. Torque is also vector. So the linear equivalence of the torque is force. You know, force is mass times acceleration. So just like force is equals to mass times acceleration, torque in terms of moment of inertia and angular acceleration. So torque is equals to I times alpha, that is torque is equals to moment of inertia times angular acceleration. Work done by torque, just like work done by force, linear force. This is angular force, angular or rotational force. So the linear terms of work done by a force is F dot S. F dot S. F mean vector, the force that is vector, and displacement that also vector. So the dot product of the two vectors, it gives work done. That work done is scalar. Likewise, when the torque turns about a body, the work is does, that is torque times theta. Torque is the turning effect or the rotational force. Theta is the angular displacement or the angle subtended. So work done, rotational work done, is equals to torque times angular displacement. So the torque multiplied by the angle to be turned through. So the law of conservation of angular momentum, if no net torque acting, the angular momentum of the system is conserved. No torque, the sum of all torque is zero. The sum of all torque that act on the rotating bodies is zero. Then the initial angular momentum and the final angular momentum is equivalent or equal. This is the law of conservation of angular momentum. So Li is equals to Lf. Li mean the initial angular momentum, that is equal with Lf. Lf mean the final angular momentum. Li mean the angular momentum, which is inertia times angular velocity. Li, the initial inertia times the initial angular velocity, that's equivalent with the final momentum of inertia times the final angular acceleration. So let's back to here's the simulation of angular momentum. Here I give a degree, that is 57.3 degree per second. This angular displacement or angular velocities, angular velocity that is given which is constant velocities, angular velocities, and here the angular velocity, vertical one, and horizontal the time, and the moment of inertia that also vertical, and horizontal that is time, also the angular momentum that's vertical, and the time is horizontal. So what is will be done? So here the angular momentum or angular velocities is 57.3 here in degree per second, and it is what constant, within a constant angular velocities within every t, and the moment of inertia of a disk, that is half of m times r square, half of m times r square, when the r is 25, and watts, let's clear it, and 57.3 is the given one in degree per seconds, and the mass of the platform is 0.25, and the radius of the disk, that is 4 meter. So the moment of inertia is 1/2 times m times r square. Here r square mean 4 square, that is 16. 60/4 is 60/4 is what? 4. 4/2, that is 2. Okay, it's good. Therefore here the moment of inertia is 2, moment of inertia, and the angular velocity, that is 57.3 degrees per second, and the angular momentum, that is 2. Angular momentum, that is what? Angular momentum is I over omega, I times omega. So L is equals to I times omega. I is 2, and omega is what in radian? 1 radian. So 2 kilogram meter square times the radian, 1 radian, that is 2 kilogram meter 2 kilogram meter square per second. This is angular momentum. So when no net torque is acting on, the angular momentum is conserved, which means the initial one is equal with final one. Here it is the constant one. So this is all about introduction here, and the torque of here. Torque is equals to the product of force and radius, perpendicular radius, that is torque is equals to F times R, that 1 times 4 is 4, and the moment of inertia here, also moment of inertia of the disk, that is half of mr square, and the moment of inertia is also here seen. Thank you. Please like, subscribe, and share as you respond.
With